chapter 1.4 on color. Pardon my roosters having some issues over here, you might hear them. So, color is the most vivid element of art and it attracts our attention. And I have a lot of students write about color, whether there's color in the work or not. Be careful when you're choosing in elements and principles to choose what's most appropriate, not what's easiest to write about. It has to match the work, okay? So I'm just going to say that. Perceptions of color, back on track here, are personal and subjective to a degree. Men and women have very different color ranges. Men in particular have a wider color range from blue to yellow. So they might perceive things as more yellow or greenish compared to other men, and the bracket is, say, 0 to 100 for men. Women fall between 25 and 75, if that makes sense. I don't know the exact number, but it's something like that. I see very much to the end of the yellow spectrum. I often think things are green when they're actually blue. So sometimes things can be very subjective. Red-green color blindness only happens in men, and it's pretty rare. So color and light, there's a relationship there. You can't see color without light. We know this because we're walking around at night and we can't see what color things are. We remember what color it is and then we kind of build that association in, but we don't really see that color. So white light is separated into the spectrum, and when you think about spectrum, you can use the word rainbow. It's almost the same. It's not quite the same, but it's similar, okay? So the spectrum and the rainbow are similar in the way that the colors break down and they come out in stripes. Each color has a different wavelength. So we're looking here, see how this is similar to a rainbow? The prism was invented, oh gosh, I think it's by Mr. Isaac Newton, I'm pretty sure. Sorry about that. It's in my other book. It's not in this book. Anyway, so the prism was an interesting way to perceive light, and it goes through, the light will go through here, and then it would bend, and therefore the colors would come out. And that's kind of what's happening in a cloud. You don't see rainbows on a crystal clear day. There has to be moisture in the air. So the moisture in the air, if the light is hitting it just so, will act as a prism, and then you will have that rainbow, okay? But I don't want to get you too off track with the rainbow. I just want you to think of something that you know in the world, in nature, that you've seen before to relate to. So light's going here, it bends it into the visible spectrum. Now there's some invisible colors on infrared on the other, ultraviolet over here, that we cannot see with the human eye that do exist. So the colors we see in objects are not the colors they are, if that makes sense. It's the colors that are reflected back. So other colors of the spectrum are absorbed by the pigment in the object, and reflected color excites nerve cells in our eyes, and it's interpreted by our brain. Our eye is not doing really all that much work. It's really our brain. So this is a really great diagram. I've used several other books, 2 other books really in particular, for this topic, and I think this is really nice the way this Gateways gives us this imagery here. So we have this whole rainbow of color coming from a light source, all the colors in the rainbow. We're hitting a sweater, and what we're seeing is blue because that's the part that's getting reflected back. And I don't know if that's really making any sense to you at all, but it's absorbing the rest of the rainbow or the color wheel. So additive and subtractive color are slightly different depending on the medium you're using, and by that I mean light versus pigment. So beams of light, when we're doing theater lighting, which we're not doing in this class, but we're going to talk about it anyway, when you're projecting lights, like if you're looking at a concert, right, or a play, and you're seeing these lights projected onto the person or onto the band or whatever, that's additive color. So if you added enough colors together, if you put yellow light and red light and green light, you would get toward a white light, right? So the more beams of light that you're adding with colored, like gels on it, or colored beams, we don't really have colored beams, but we have these things to make the light change color, then you get lighter results. Now, pigment is the 90% of what we're going to use in this class, 90%. So I'm not going to get too into this additive color. I'm going to get into subtractive color. Okay, so this is subtractive color. I know it sounds backward, but when you mix pigments together, because you're adding them together, so it doesn't make, I don't really like this terminology that well, but anyway, when you're mixing pigments together, you keep adding more colors together, then you get darker results. You get like a murky blackish gray. Okay, so when you mix all these pigments, you're putting more of the spectrum. You're absorbing more of the spectrum is absorbed, if that makes sense. Okay, so this is Charles Tzuri. It's a Wondrous Spring, and this is a light-oriented piece because it's a digital piece made on a computer. Okay, so it's viewed only on video displays. So these things are happening in the world where artwork is simply on the computer, on the internet. So we're only looking at it in that way. So it's using additive colors, meaning light of red, green, and blue light. So we'll go back and look at it for a moment. So these are lights, so it's very different than if this were pigment and paint added together. It has a very different effect. Alright, so color wheels are something that we are going to do in this course. We're going to do one. And if you're smart, you will have watched this video because this will help, and you will look at the book. Page 103 has a good one. And I think that's the one we want to use. I think we have some other ones on here that are going to be confusing. So 103, the piece by the Kandinsky piece, that the figure 1.4.3 traditional 12-step color wheel. That's what we want. This is from the 18th century, and scientists and color theorists, I don't know who those people exactly are, those color theorists, but Kandinsky kind of is one. Anyway, but he's in the 20th century. But at any rate, a lot of people wanted to think about a map of how the relationships of color, and hue means color, okay? Hue, that means the type of color it is. So we're going to look at additive and subtractive color wheels. This is a standard pigment, meaning paint or print making ink, or even, well, let's think of what else is in a pigment. Crayons and watercolors, oil paint, chalk, that kind of stuff. Okay, that is the color wheel right here. So this is how it works. This is what you're going to replicate, and you're going to paint this, and you're going to mix these colors. Now your particular paint with your primaries, this is all you need is yellow, red, and blue. Those are our primary colors. That's all you need, and then you mix these two together, then you get green. That's a secondary color. Violet's a secondary, orange is a secondary. These are all tertiaries, and then you got to be careful not to overdo it with the blue and the red. Sometimes those are quite strong. So this is our standard color wheel. It has 12 colors. It has 3 primaries. It has 3 secondaries. It has 6 tertiaries, means third, means one primary is 1. A secondary is 2 colors. A tertiary is a mixture of 1 primary and 1 secondary. 1 plus 2 equals 3. Okay, we talked about this. Go back over it in the book. Kandinsky. Now he is very he's a really early 20th century person. This is 1925, and he made a lot of discoveries in art. He's Mr. Non-subjective artwork. He does a lot with the elements and principles, with the line quality, but color is also his thing. So he has blue, red, yellow. So this is mainly primaries with a few other things. And look, he kind of plays around here with a couple of squares of color right there. So he uses primary colors plus black and white, and he is simplifying and celebrating art in the purest sense. So he starts to really think about the elements and principles, and he's one of the people who begins to start to put those things in that kind of an order, the things that we're going to look at. Basically all of the first part of the book, part 1, all the chapter 1.1 to 1, or sorry, 1.1 all the way through 1.10. Okay, so this is a CMY pigment color wheel. Now this is confusing. Now I'm just going to go over this very quickly. This is meant for a printer, like you know, printing posters and things like that. And it is different. The cyan is a very different kind of a color, and you don't find this in paint exactly. It's in printer's ink. This is a different thing, and this is how things are printed on your computer. If you print things out on a color printer, you'll notice you have 3 cartridges plus black sometimes, or you have one that says 1, 2, 3, has the yellow, cyan green, and the cyan blue. Sorry, it has yellow, cyan, and magenta. These are the primaries. Okay, so things are different, and then you'll have black. But you can get black from combining these 3. Just some people want a crisper black, so they throw a black cartridge in there as well. I'm going to skip this. We don't use it a lot in art. We do use it in printing. So this is a map of subtractive color. I'm going to stop here.